circuit analysis mesh method. How to apply that method? Let me draw a sample circuit and try to apply the mesh method. The value is I source 1, the value is V source 1, R1, R2, R3, R4. Okay. Remember what's mesh? Remember mesh? Inner loops. So how many meshes are there in this circuit? Let me define the meshes. Mesh 1, mesh 2, mesh 3. Okay. So I can say the first step is steps 1. Define meshes. And mesh currents. Okay, there is a mesh here. Assume that there is a current flowing starting from this point. Okay, it flows like that. Okay, assume that there is a current flowing on this mesh. Okay. Of course, there is no starting point, it's a continuous current, but I start to draw the mesh from a point. Assume there is a current in this mesh. Let me say, and let me give a name, I1, mesh current. Okay, what's I1? I1 is the current flowing on the first mesh. The second mesh current is I2, the third is I3. Because there are 3 meshes, I have defined 3 currents. And then, for example, what's the current of this source in terms of mesh currents? I1. Okay. What's the current of this resistor in terms of mesh currents? I1. I will define all currents in the form of mesh currents. What's the current on R2? I1 is flowing down, okay, through the bottom side, and I2 is flowing upwards. So I1 is in the same direction, I2 is in the opposite direction. I1 minus I2. What's the current of R3? I2. What's the current of R4? I2 is in the same direction, so I will say plus I2. I3 is in the opposite direction, as you see I3 is upwards, minus I3. Okay. What's the current of V source 1? Voltage source 1, I3. Okay, I have defined all component currents in terms of mesh currents. Okay, and then I will apply So the second is write component currents using mesh currents. Okay, I have written the currents of components in terms of mesh currents. Then the next step is write KVL equations on meshes. Okay. Remember, node method was the application of KCL. Mesh method is the application of KVL. We will write KVL equations. Let me copy my circuits and try to write the KVL equations. Can you help me? Start from traditionally, okay, it's easy for me to start from the left bottom side. You can start from any node, but I always start the left bottom node of the mesh. Okay, I will add the voltages. So first let me define some voltages for the components. Let me say this is the fourth, but the third is define component voltages in terms of mesh currents. Okay. For example, let me say this is we source 2, let me say, in order not to confuse. This is the second source. Okay. Let me say this is V source 1. This is V1. This is V3. This is V2, V4, and that's already given, V source 2. Okay, so what's V source 1? We don't know, because it's a source. I cannot write a relationship between the currents. Okay, there is no relationship between the current and voltage of source. What's V1? Voltage of resistor 1. I have to write the voltages in terms of mesh currents. R1 times I1. V2 R2 times the current. What's the current of R2? I1 minus I2. V3 resistance times current. Okay. V4 resistance times currents. What's the current of R4 in terms of mesh currents? I2 minus I3. What's the voltage of source 2? It's already given. V source 2. That's given. We don't know the current, but the voltage is given. And then I have defined the component voltages in terms of mesh currents. Then let's write the KVL equations on meshes. So I will write 3 equations because I have 3 meshes. Okay, so mesh 1, start from here, minus V source 1, minus V source 1. Okay, I can write, if I see a minus sign, I will write minus. If I see a plus sign, I will write plus. Or let me write like in physics, if I switch from minus to plus, it means there is a voltage increase. So I will write plus V source 1. Then there is a plus to minus drop. There is a voltage drop. So I will write minus V1. Then there is an again plus to minus voltage drop, V2. I have returned the same point, 0. Okay. And I need to write that equation in terms of mesh currents, because I will solve the system of equations for mesh currents. Okay. So let's write the same equation using mesh currents. Same equation, V source 1. There is no relation between the mesh currents and V source 1. V source 1 is a voltage source. I don't know its voltage, but I cannot write a relationship between the currents. So it remains same. V source 1 minus V1. What's V1? Voltage of a resistor. Look at here. V1 is R1 I1. R1 I1 minus V2. V2 is R2 times I1 minus I2. I have returned the same point. Summation is 0. Okay. Similarly, I have to write the mesh equations, all mesh equations, in terms of mesh currents. So let's write the second mesh. I'm starting from here. Minus V2. It means there is a minus to plus. There is a voltage increase. I will say plus V2. What's V2? V2 is resistance times current. Resistance times current. I1 minus I2. Okay. Then continue. Plus to minus. There is a voltage drop. Minus V3. What's V3? Resistance. V3 is resistance times current. V3 is R3 times current. Continue. Again there is a voltage drop, V4. Minus V4. V4 is R4 times I2 minus I3 is equal to 0. Why? Because I have reached the same point. Okay. The next one, the last mesh equation. I will start from the left bottom. There is a voltage increase, then there is a voltage drop. Summation is 0. Mesh equation 3. Voltage increase, V4. V4 is R4 times current. Continue, and there is a voltage drop because I switch from plus to minus. Minus V source 2 is equal to 0. Okay. Look, there is a current source here. Its value is given, I source 1. Capital I source 1. It is given. What's the current of this source in terms of mesh currents? Can you say me? Small I1, isn't it? So actually in this circuit, small I1 is very obvious. Small I1 is what? I source 1. If there is a current source in the circuit, it's very easy to see some mesh currents. Small I1 is I source 1. It's given. So how many equations do I have? 1, 2, 3, 4 equations. How many unknowns do I have? How many unknowns? Unknowns. I1. Actually, I1 is known anymore. Okay. I2, I3, and what? V source 2. I don't know these values. Okay. So number of unknowns are 3. How many equations do I have? 1, 2, 3. Okay. Number of equations equal to number of unknowns. So this system can be solved. Okay, you can solve this set of equations. 3 unknowns, 3 equations. So after finding mesh currents, okay, if you solve this system of equation, you will find mesh currents. For example, how can you find V4? It's wanted. Okay, what's V4? You will use mesh method to analyze that system, and then how to calculate V4. After finding mesh currents, you will say V4 is R4 times the current. Current is I2 minus I3. Okay. Here, V4. Let's have a numeric example. So, after writing KVL equations on meshes, okay, then the fifth step, step 5, solve equations for mesh currents. Okay. Example. Question: what's V2? Use mesh method to analyze the circuit. If actually you can use many other methods, okay, it's a very simple circuit. You can analyze easily that circuit. But to explain how a mesh method works, I will solve this equation. I will analyze that circuit using mesh method. Okay, step 1. Define mesh currents. How many meshes are there? 2 meshes. Okay. Mesh 1, I will say current of that mesh is I1. Mesh 2, I2. Okay. I will write the KVL equations, but before that equations, I have to write the voltage current relationships of the components. Let me define some voltages first. V1, that's already defined. Let me say V3. Okay. So what's V1 in terms of mesh currents? What's V1? Use Ohm's law. Resistance times current. What's resistance? 3. What's current? What's the current on it? I1. Good. V2. Resistance times current. Resistance 8. Current. But I have to use, in Ohm's law, I have to use that current. It's entering from positive, exiting from negative. Okay, so I1 supports the Ohm's current. I1, because it's in the same direction of Ohm's law current, minus I2. Okay, what's V3? Resistance times the current entering from positive, I2. Then let's write the equation, mesh equation 1 here. Start from the left bottom. For me, okay, you can start from any point. There is a voltage increase of 15. Then there is a voltage decrease of V1 minus V1. What's V1? 3 times I1. Okay. Then there is an again voltage decrease, V2. And I have returned the same notes. Okay. Summation is 0. Then the second mesh equation, I have started from the left bottom side of that mesh. There is a voltage increase of V2. V2 is 8 times I1 minus I2. And then continue, there is a voltage drop of V3 minus voltage drop minus V3 is 5 I2 is equal to 0. (15 minus 3 I1 minus 8 I1 plus 8 I2 is 0. So minus 11 I1 plus 8 I2 is minus 15. That's the first equation. Rewrite the second equation. 8 I1 minus 8 I2 minus 5 I2 is 0. Okay. So 8 I1 is equal to 13 I2. I1 is equal to 13 divided by 8 I2. So I will use the back substitution technique. I will use equation 2 in equation 1. Okay. Minus 11 I1 minus 11 I1. Instead of I1, I will write this. Minus 11 I1 is equal plus 8 I2 is equal to minus 15. Okay, so if you solve the system of equation, I2 will be 1.52, and then I1 is equal to 13 divided by 8 times I2, which is equal to 2.47 amps. And the question was, what was the question? V2. Find V2. Remember, what's V2? V2 is resistance times the current. The current of this resistor in terms of mesh currents is I1 minus I2. Okay, the total current flowing on that resistor. So let me calculate this value. 8 times minus I1 minus I2, which is equal to 7.6 volts. Okay, so you can find anything, okay, any value of the circuit, because you know the currents, you know the resistances, you can calculate the voltages, you can calculate the powers, everything.